Hello friends. In the comments under my previous video, where I talked about the advantages and features of Zigbee devices and the structure of a mesh network, if you haven't watched it yet, the link is in the description. There were many requests for a follow-up. So, in this video, I will update some of my lessons as of March 2025 and show a simple method to update the firmware of the Sonoff ZB Dongle P USB Zigbee coordinator and similar devices. I will also discuss the Zigbee2mqtt add-on, how to install and configure it, as well as other necessary add-ons and integrations for its operation. One of the most popular and widely used ways to work with Zigbee devices, not only in Home Assistant, is Zigbee2mqtt. Unlike the ZHA integration reviewed in the previous video, Zigbee2mqtt is a separate, independent system that does not directly depend on Home Assistant. Speaking of the advantages and disadvantages of ZHA and Zigbee2mqtt, the most obvious advantage of Zigbee2mqtt is its extensive database of supported devices, which expands with each update. For example, at the time of recording this video, there are over 4,000 devices from nearly 500 manufacturers. Additionally, Zigbee2mqtt allows adding support for new or even custom devices using external converters, description files containing instructions for working with a specific device. ZHA takes a different approach, where support is not at the device level, but rather at the level of the data received from them. For example, if you define a data exchange process once, such as temperature reporting, the integration will work with all sensors that support this process. Meanwhile, in Zigbee2mqtt, descriptions are tied to the model number and unique device identifier. In theory, the ZHA approach is more correct, but in practice, not all manufacturers strictly adhere to Zigbee standards, which makes it necessary to create individual descriptions for each device. As I mentioned in the previous video, ZHA is an integration, an add-on that is part of Home Assistant itself. Zigbee2mqtt, on the other hand, is a separate system. However, due to Home Assistant's popularity, it can be installed as a standard add-on directly from its interface and can interact with it. However, this interaction is not direct. An additional add-on, Mosquitto Broker, acts as an intermediary between Home Assistant and Zigbee2mqtt. It is a server that systems and devices supporting the MQTT protocol can connect to, as implied by the second part of the Zigbee2mqtt name. In Home Assistant, data exchange with this server, handled by the Mosquitto Broker add-on, is done via an integration, which is a built-in Home Assistant component called Mqtt. This setup is more complex than using ZHA, where only one integration is needed. As the coordinator, and I discussed the role of a coordinator in a Zigbee network in the previous video, I also decided to use one of the most common options, the Sonoff ZB Dongle P USB stick. Visually, it looks very similar to the ZB Dongle E reviewed in the previous video, but when placed side by side, the ZB Dongle P is slightly larger. In this photo, the ZB Dongle P is at the bottom. Before starting, it makes sense to update the firmware to the latest version. Here, I will show you a simple way to do this directly in Home Assistant. We will need one more add-on. Plug the stick into the Home Assistant server. This is one of my test servers with a nearly clean installation, except for a few basic add-ons. File Editor, which is needed to edit files, and which I will use for this purpose. The MariaDB database and Matter server are installed but are not relevant to this lesson. I will leave a link to my video on installing basic add-ons in the description. At the bottom right, there is a button to access the add-on store. Unlike the mentioned add-ons, which are part of the official repository, the one we need must be added manually. To do this, click the three-dot button in the top right corner and select Repositories from the menu. In the next dialog, insert the link to the required repository. Right now, we need the ZigStar Add-on, and I have left a link to it in the description. Copy and paste it here. Click the Add button. The repository name will appear in the same dialog. Now, you can close it. Refresh the page in the browser. F5 is usually used for this. Look for a new section called ZigStar Home Assistant Add-on Repository. It offers 3 different add-ons, each intended for updating the firmware of a specific category of coordinators. For the Sonoff ZB Dongle P, we need the one for CC2652P chips. To work with this add-on, it must be installed. This process takes some time. After installation, do not start it yet. Do not enable any options. Automatic startup and updates should be disabled. Next, go to the Configuration tab. This is how it looks by default. All options are disabled. One of the ports displays a long string. This is our coordinator, whose firmware needs to be updated before starting work. For the Sonoff ZB Dongle P, select the port where it appears. In the network address field, enter any symbol to prevent it from being empty. Then, enable 3 toggles. The first sets the working mode needed for flashing the USB coordinator. The second is specifically designed for updating the Sonoff ZB Dongle P. The third allows the add-on to automatically select the latest available firmware version. Save the configuration. If you make a mistake, such as forgetting to enter a symbol in the network address field, the configuration will not be saved and an error message will appear. If everything is correct, the settings will be saved. Return to the first tab, Info, and only now start the update. Do not change the toggles. Go to the Logs tab. If everything is done correctly, the firmware update process will look like this. Do not touch anything, just wait. It will not take long. The firmware update has been successfully completed, and all services have been stopped. You can return to the Info tab. Stop the add-on. It is no longer needed for now. You can delete it, but it is better to keep it. When new firmware versions are released, it may be useful again. Once again, I want to emphasize an important point I mentioned in the previous lesson. The USB coordinator can only work with one system at a time. If you have configured ZHA and this coordinator is compatible with it, then it will not work with Zigbee2mqtt. I connected it specifically to show you, but you do not need to do this. Here is the firmware version it was updated to, 202.40710. This is simply the release date in the format year, month, day. The coordinator itself works perfectly fine in ZHA. Everything I showed in the previous video with the Sonoff ZB Dongle E is also relevant for the P version. For an experiment, I added one device. Everything works correctly. Regarding the question of which coordinator is better to use with ZHA, I believe that devices based on the EFR32MG21 module, such as the ZB Dongle E, are the best option. The P version, based on the CC2652P, is more stable for Zigbee2mqtt. However, in most cases, EFR32MG21 will also work without issues. If you have added the coordinator to ZHA and want to use it with Zigbee2mqtt instead, you need to remove it from ZHA. It should not be in ZHA. However, if you wish, you can connect another coordinator, such as the mentioned ZB Dongle E, and use 2 separate networks, ZHA and Zigbee2mqtt, to compare them. Returning to our topic, we now need to install Mosquitto Broker. This is an official add-on from Home Assistant. Install it and wait for the process to complete. Do not start it yet. Go to the Configuration tab. By default, the settings look like this. For use with Zigbee2mqtt, nothing needs to be added or changed. However, in the future, Mosquitto Broker may also be useful for other purposes, such as connecting devices with specialized firmware. And for this, you need to set up a login and password that the devices will use to connect. It is easiest to do this immediately after installation. As an example, the login and password are set to Mqtt. If you do not want to type them, you can copy them from the description under the video. If desired, you can set a more complex one. Save the settings. In the network settings block, do not change anything. It is best to keep all ports in their default configuration. As I mentioned, Mqtt is a widely used protocol in smart home systems, and the server component can be useful not only for Zigbee2mqtt. Now, go back to the Info tab and start the add-on. In addition to enabling automatic startup after reboot, you should also enable Watchdog. This ensures that the add-on restarts automatically if it crashes. For monitoring the startup process, you can go to the Logging tab. If everything is set up correctly, you should see something like this. A successful discovery message in Home Assistant, as indicated in the second-to-last line, means that the Mqtt integration, which I remind you is a built-in component of Home Assistant unlike add-ons that function as separate modules, has detected the installed server. Go to the Integrations menu. As expected, a new tile appears, suggesting you add Mqtt. Next, a clarification appears. It confirms that this is the same Mqtt broker that was installed as an add-on. This means the one we just installed. In reality, it could also be installed separately, without Home Assistant, and on a physically different server. Once this is done, the integration establishes a connection with Mosquitto Broker. This means it will monitor a special directory, called a topic, in Home Assistant. Devices and systems that support Home Assistant discovery will create topics there for objects that Home Assistant will interact with. I have left a link to the Mqtt Explorer software in the description. This is an Mqtt server browser that allows you to view and manage data stored there. To connect, use the IP address of your Home Assistant server, where we installed this add-on, the default port, which we did not change, and the login and password we set in the configuration. The server has just been installed, and no devices are connected yet. The Mqtt integration is only monitoring the Home Assistant topic, which has not been created yet. For now, there is only a service topic containing technical information about the server. At this point, there are no devices in the integration yet, but we will soon fix that. Some of this information may seem excessive, but I want you to understand how all these modules interact with each other. Referring back to the diagram I showed at the beginning, we are currently at this stage. The Mosquitto Broker server component is installed, and Home Assistant has connected to it via the Mqtt integration. And now, it is time to install Zigbee2mqtt itself. I think by now, you understand why it is called that. It connects a Zigbee network on one side and Mqtt on the other. This is an independent system, so it is also installed as an add-on. Its repository also needs to be added manually, just like we did when updating the USB stick firmware. The link to it can also be found in the description under this video. Add it. Now, we have 2 custom repositories added. Refresh the page in the browser and find the Zigbee2mqtt section. It offers 3 versions of the add-on: Standard, which we will install, Testing or Development, and Proxy for external Zigbee2mqtt installations. Install the standard version of the add-on. Do not start it yet. I want to cover a few common questions. Go to the Configuration section. By default, nothing needs to be changed here, but I want to point out this line. The path to the folder where the add-on will be installed is /config/Zigbee2mqtt. Just take note of it for now. I will explain why later. Now, we need to determine the name of the port where our USB Zigbee stick is connected. To do this, go to Settings, then System, and select the last option, Hardware. Click the All Hardware button. Scroll down to the list of ports. Here is our Sonoff ZB Dongle P. I always use the short port name TTY-USB0, and in all cases I have encountered, it worked. However, based on feedback from others, some people have needed to use the longer path, which is displayed below it. To ensure Zigbee2mqtt starts correctly with all basic settings on the first try, I recommend taking the following steps. Manually create the folder where the add-on will be installed. Remember, we checked this path in its configuration, which is /config/Zigbee2mqtt. Here, It appears as /home assistant /Zigbee2mqtt. The /config/ and /home assistant/ directories are the same. Next, go to this folder and create a file named configuration.yaml. Here is my recommended initial configuration.yaml for Zigbee2mqtt. It is adapted for use with version 2 and above. A text version of it is linked in the description under the video. The first block relates to the Mqtt server. It specifies the server address and port, using the local option since this add-on runs on the same server, and Zigbee2mqtt will connect to it over an internal virtual network. The base topic for the add-on is set to the default, and the version number is included to help prevent certain errors. Next, the coordinator settings. We specify the port, the one we just checked in the hardware settings. The type depends on the Zigbee chip in use. For CC2652P, the type is stack, and for EFR32MG21, it is Ember. In the advanced section, I include an option to set the maximum power level. Honestly, I do not see much difference, but I keep it enabled out of habit. I will not claim that it is necessary. The channel number determines the frequency range of your Zigbee network. The default recommended channel is 11, with 15 and 20 also being common. Some devices may not work on non-standard channels. PAN ID and network key are somewhat like the SSID and password for a Wi-Fi network. Before the first launch, enable the option for automatic generation. Above this section, there are standard options for whitelisting and blacklisting devices, which do not need to be filled in. Last seen enables the display of the last response from Zigbee devices. The logging level is also defined here. The Home Assistant section. The first option enables interaction mode, informing the add-on that it should work with the corresponding topic monitored by the Mqtt integration. The second option enables action sensor display for wireless buttons and switches. Many users have complained that after updating to Zigbee2mqtt version 2, these disappeared, causing inconvenience. The third option disables the experimental event entities feature, which is unnecessary if action sensors are present. This is my recommended configuration based on my experience. Device pairing mode is disabled by default. We will control this manually through the interface. These next two blocks ensure that data on connected devices and created groups are stored in separate files, rather than cluttering this main configuration file. This makes things more convenient. Now, return to the add-on section and start the add-on. Enable the watchdog option to restart the add-on automatically if it crashes, and enable Show in Sidebar for quick access. Go to the Logs tab and check what is happening. The first launch may take some time, but if everything is correct, you will see a message stating that Zigbee2mqtt has successfully started. Then, information about its created topics will appear. When devices are added, their details will also appear here. This tab is very useful for troubleshooting. If something is not working, start looking here. Now, open the Zigbee2mqtt interface from the sidebar. There are no devices yet, but we can check system details. Click the gear icon. In the drop-down menu, select About. On this page, you can check the system version, which at the time of recording this lesson is 2.1.3. You can also see the firmware version of the coordinator, which is 202.40710. I showed it earlier in the ZHA integration. This is how the configuration.yaml file now looks. A login and password for Mqtt were automatically added, but not the ones we initially set in the configuration. Instead, these credentials were generated at the level of internal communication between the add-ons. The PAN ID and key for the newly created Zigbee network were also generated. Let's take a look at Mqtt Explorer. Two new topics have appeared here. One belongs to the installed add-on and is named Zigbee2mqtt, as we specified in the configuration. The second one is Home Assistant, which was created because we enabled its support in the configuration. Physically, aside from the coordinator, there are no devices here yet. There is only information about Zigbee2mqtt itself, which is stored in the bridge topic. In the Home Assistant topic, this information is structured in a format that Home Assistant understands, categorized by device types, binary and regular sensors, buttons, and switches. Since the Mqtt integration is monitoring this topic, it has automatically created a new device consisting of 8 entities. Here are the objects available in Home Assistant that Zigbee2mqtt transmits, enabling new device pairing mode, restarting, setting the logging level, checking status, and viewing the version number. Let's proceed with adding devices. To start the search, you need to press the pairing permission button. This mode can be disabled manually at any time, or it will turn off automatically after the timer displayed on the button expires. I am connecting the same button that I used in the lesson about ZHA. Initially, the new device appears as unsupported, which is normal. The system takes some time to scan and recognize it. Once this process is completed, the device is added to the system. It can either be fully supported, like this button, or not, which will be indicated by the corresponding label. If you do not plan to add more devices, you can disable the pairing mode manually without waiting for the timer to expire. Here is the newly added button in the list. Zigbee2mqtt recognizes it and displays the correct icon. The default name is generated based on its network address. Next to it, you can see the manufacturer, model, and signal quality level. Since we enabled the last seen option in the configuration, it also shows the last time the device responded. Clicking on the name opens the device page, which contains multiple tabs. The first tab provides basic information, including whether it is a router or an end device. It supports status, model, manufacturer, and identifier. Clicking on the manufacturer's name will take you to a page listing all supported devices from that brand. Clicking on the model number will take you to the page for that specific device on the Zigbee2mqtt project website. Here, you can assign a more meaningful name to the device and add a text description. By default, the name corresponds to the technical address, which is not very convenient for everyday use. You can set a custom name for the device. If you enable this toggle, the new name will also be applied to the technical names of all associated objects, which may be many for each physical device. I usually leave the default names, but you can rename them if you prefer. The description field allows you to write any text. This text is visible only within Zigbee2mqtt. It does not affect functionality, but can make it easier to identify and manage devices. This is how the device page looks after renaming. And this is how it appears in the general device list. The names are now clearer and more readable compared to the default ones. Let's return to the device page and open the second tab, which is Exposes. Immediately after adding the device, in most cases, it will look like this, which is normal. And this is how it looks after a second. I simply pressed the pairing button quickly, which triggered a connection check and data exchange. Zigbee2mqtt now displays not only the battery level, but also the battery voltage, internal device temperature, the number of disconnections, which is not entirely clear as a parameter, the action button itself, and the signal quality level. Mqtt Explorer helps to better understand interactions, which is why I periodically return to it. In the Zigbee2mqtt topic, a new entry has been created, named after the newly added device. In the Home Assistant topic, this information is categorized by object types. This is necessary for Mqtt integration. These records are essentially links. Here is an example of the battery level sensor in the Home Assistant topic. It references the corresponding button entry in the Zigbee2mqtt topic. Through these links, Home Assistant interacts with Zigbee2mqtt. They do not communicate directly. All exchanges go through Mosquitto Broker. A second device has now appeared in Mqtt alongside the add-on's management interface, the button. In the list, it is displayed under the newly assigned name. All updates occur automatically in real time. Usually, some objects are immediately visible in the system, while others are hidden. To view the hidden objects list, click on this line. In this example, the hidden values include the last response time, signal quality level, battery voltage, and the number of disconnections. If you need one of the hidden values, for instance, the signal level, click on it and go to its settings. Here, you will find the option to enable the entity. To make the object visible and usable, enable this option. Similarly, if there are objects you do not need, you can disable them to avoid cluttering the system. After a short time, the page refreshes and the newly enabled object appears on the device page, while disabled objects disappear. These are the action sensor statuses. Remember, we enabled them in the Zigbee2mqtt configuration file. Simply pressing the button immediately displays the events coming into the system. Let me remind you how this same button looked in the ZHA integration. There, statuses are not updated. Instead, events are used. I must say, I find the Zigbee2mqtt implementation more convenient and preferable. Following the method shown in the previous lesson, you can create automations for this button by selecting the events you need and linking them to specific actions. To avoid overloading this lesson, I will also show how routers work, similar to what I demonstrated in the video about ZHA. I am connecting the same power socket with energy monitoring. This device is a Zigbee router, meaning it can connect to other network devices, extending its coverage and capacity. This is how the exposes page looks. It lists everything Zigbee2mqtt can receive from and send to this device. Most of the information is the same as in ZHA, but there is an additional countdown option. This applies to many devices, as Zigbee2mqtt often provides more settings and options than ZHA. The device, along with all its entities, is automatically added to Home Assistant via the Mqtt integration. You already know how to enable needed options and hide unnecessary ones. Let's check the network map, which can be accessed from the add-on interface. Start building the network map. The larger the network, the longer it takes to build the map. Since there are only 2 devices in this case, the map was generated quickly. Now, let's consider a scenario where you need to specify a particular router. Open the drop-down menu next to the Pairing Mode button. By default, the system operates in All mode, where the network decides where to connect a new device. However, you can manually select a specific connection point, either the coordinator or one of the routers. In this example, there is only one router. Now, the text on the button indicates where exactly the new device will be connected. The rest of the process follows the standard procedure. I remind you that devices in a Zigbee network can change their routes autonomously, so there is no guarantee that the newly connected device will remain linked to the same router in the future. This is a water leak sensor, the same one I used in the ZHA lesson. I deliberately repeated the process, but this time in a different system. This is how the network map looks. But as I mentioned earlier, the network is dynamic. The more routers you have, the more routing options become available. As an example, here is the map of one of my working networks. I currently use 3 separate networks. The routes constantly change, and if I were to build this map a week later, the connections would look different. During periods of frequent power outages, the end devices would automatically connect to the coordinator and routers that had backup power. In the upper right section of the map, there are several checkboxes that control different types of connections. This allows for a more detailed understanding of the network structure and, in some cases, helps identify possible issues. Although there is still much more to cover, it is impossible to fit everything into one or even several videos. So, we will wrap up here. I would love to read your thoughts on these lessons in the comments. I hope this video was helpful and interesting for you. I would appreciate your likes. They help with visibility on YouTube. If you do not want to miss future videos, consider subscribing to my channel. In the video description, I will include links to the resources and lessons mentioned, as well as my Telegram channels and social media pages. There are also groups for discussions about smart home topics. Feel free to join. It will be interesting. Thank you for watching. Until next time, peace to all.